Hey guys, how's everything going? This is JSer, who is not good at algorithms. I'm recording this video to prepare my interview. In this video, I'm going to take a look at 199 binary tree right side view. Wow. We're given a binary tree. Imagine myself standing on the right side of it. So view the tree from right. Return the values of nodes I can see in order from the top to bottom. Okay, so 1, 2, 3, something like this. So it should be 1, 3, 4. Well, it's obviously that this should be a BFS, right? Breadth first search. I mean, we should get each layer, get the nodes by layer, and just get the rightmost items, right? So yeah, it's obvious. So it's BFS. How can we handle BFS in tree? Remember, it's queue, right? Yeah, let's create a queue. And let's create a queue, push the root in, and every time we get the items out and push the next layer items in. Right? Cool. Let's queue. We in JavaScript use an array to do it because we have shift method, and this should be root, right? At first we push root in. So while queue length, while there is elements in the queue, So how should we do it? Do we handle null method? Null elements? No, we just push them all into the queue. So every time we will get the elements all of the layer out and then push the next node in, right? Cool. But how should we know, because we are using the same queue, so how should we know that it is ended? Well, there's a trick. We could push a null element in, right? Or there's another method using index. Let's try both. First, I'll use it using adding null node in the queue. Push and a null as ending identifier. Okay, queue push null, let head while head equals queue the shift. So this will help us get the node, push the node, get the node layer by layer. So this while loop will do everything. Okay, for the result would be empty root values. I can see if this null. Okay, don't forget if root is null, nothing, right? So and then we could say it is initialized as this. And okay, now, oh my bad. Every time we get a layer, and we will get a layer, we will do what? We will update the last one in every while loop and set the value to it, right? So here, when this is done, we get the head, but it's null, and then we push the element, right? But we need to get the index. Let's say let rightmost val okay, here set it to head val, and this will be updated. There's only one variable. This will be updated over and again for each layer, right? And then at the last one, it will be the rightmost one. So and then we should just we could just push result, push the rightmost val. But don't forget, we need to push new elements in the queue, right? If head left, push the left. If head right, cube push head right. And when each layer is done, and then push the rightmost valve. Right, and then last, we will return the result. Let's review this one more time before we run the code. If the null is null, we return empty, and then we use an array and push the root in the queue. And every time we will pick up all the elements, and we push the null as an any identifier. Every time we get the head, we're using shift, and we update the rightmost value to that, and push the elements, push the nodes in the next layer to the queue, and then yeah, so that's it. Let's run the code. Huh? What? Out of memory? What did we do? Out of memory? Allocate row with retrieve. Out of memory? Really? If you use 3, even What? If it is only 1, 2, 3, still out of memory? Oh, wow. There's must be something wrong in our while loop. While its length is bigger than 0, we pushed null, and then shift it until we get the null. If left, we push left. If right, we push right. And then we push the rightmost valve. So this should end. What is wrong? Let's see. One, 1, 1. So there's one element. We shift. We keep shifting. We push a null. We shift. This will end when we get null, right? Oh. This is weird. Something I didn't see. Oh! My God. Cool, we're accepted. So, wow, I made a super stupid mistake. Now let's analyze the time and space complexity. Time, every node has actually traversed through one, so it's linear. Time, space. The result should not be counted as extra space, so we use a queue as a helper queue. And this worst case will be the length of the nodes, right? So worst case is linear. Worst. Cool. Now let's recall that there's another way of writing it without using an extra null. Checking end of layer by index. Personally, I like this check. I like this. I like this trick. Well, it's easy to understand, right? Sometimes we need the null in the queue. For that case, we need to push the undefined. Well, there's still another way. Instead of pushing the null, we keep track of the index, right? Or not. Yeah, we could get the last node of layer equals q.length -1, right? And we could compare that. While we get head, we shift it. While what? While we will stop if head equals to the last layer. We could break, right? Yeah, this also work. This also work. Yeah. Well, there's another way. Instead of just getting the top element and do things, we should do something like counting, right? Like a count of this layer equals q.length. This is the count. So we should say when there is no elements in this, when there is no element, when there's still element, we get the head. We get the head is q shift. This should still work, right? No, count of this layer, const. Oh, my bad. Yeah, this should work. Also, anyway, this is by checking index or checks the element or checks extra any identifier. So I personally like this way better. Anyway, so hope it helps. See you next time. Bye bye.